In this video, I wanted to talk about caching, and specifically a multi-layered filtering cache that I'm trying to put together for my ASP.NET Core application. So we're going to be looking at the first part, the multiple layers and how that's structured. And then the second part is about filter sets of IDs that come back from when we're running filters against a database. So before I jump into the code, I just wanted to touch on the point that I made in another video, and I'll put a little link up here, where there's opportunities where, like, as software engineers, like, someone has probably written the thing that you're trying to do. And I think in a lot of my projects, I do try to take the the hard way, right? I try to do stuff on my own so that I can learn about it. And when I don't find something that fits exactly what I want, sometimes I'm like, hey, this is a good opportunity for me to try it, for me to learn about it. And then on my journey, if I come across something where I'm like, actually, this fits better, I can always swap over to that. So I just wanted to share that perspective because this would change a lot if I had paying customers, or this is for my day job and I needed to deliver faster. I would probably spend less time building on my own and more time sort of finding resources that fit. So I wanted to share that first, just so it's that's a little disclaimer before we start looking at my code. And with that said, let's go to Visual Studio and start looking at the multi-layer cache. All right, so on my screen, I am showing the interface for an iCache layer, and it's pretty simple. It's actually really just kind of copied from what we have accessible in the distributed cache that comes from ASP.NET. And really, we just have the ability to try pulling things out, setting things, refreshing them, and removing them. So really simple API, kind of, the basics that you would expect on a cache. But what's the deal with the multi-layer part? Well, when we're thinking about applications, we are familiar with things like in-memory caches, right? You could quite literally have a dictionary somewhere that is a basic cache. I personally like to use, I'm just going to jump over to it, this library called Bitfaster. They do have a handful of different variations for different types of caches. I really like this fast concurrent TLRU cache. Personally, I just find that it fits almost all of my in-memory needs for really basic things. And you can see that all that I've done here is I've wrapped all of the API methods off of this cache layer around the Bitfaster cache methods that kind of match up to it. They're not perfectly the exact same, but it fits, it works, and for the most part, this will be a really basic in-memory representation that I'll be using for my multi-layered cache. But what other layers would we consider? Because if we already have something like a in-memory one, I had another example I'll just pull up, might look almost the exact same, but this is just a dictionary. If we have two variations of in-memory caches, like, what else would we want as a layer? Well, what about a distributed cache? So there's lots of flavors of this, but in particular, I wanted to start looking at backing up my in-memory cache with something like Redis so that I had way more opportunity to store things in the cache and not really stress my application server by slamming more things into RAM. I could have another, instance in the cloud that is my Redis cache, and that way I can have dedicated resources for caching and not have to worry about other performance implications for my application server. Just to jump over to this other project I have, this distributed cache layer. This one is a little bit more complicated, but what I thought was really handy was that I can basically wrap anything that is implemented with this iDistributed cache that comes from this Microsoft Extensions caching distributed namespace. So a lot of the ASP.NET Core caches that, the packages that people might want to use, Redis or other things, a lot of them will implement this iDistributed cache. So I thought this was going to be a super handy way to basically say, if I want Redis or something else, I can pass in that dependency here and then through these other methods, and you can see that I have a couple other things like for converting the keys and the values. This way I can interface directly with an I-distributed cache like Redis and take advantage of that. So I'm not going to walk through all the specific details of how this works, because for the most part, you can consider this almost like a pass-through. It's just that there's a little bit of extra logic to be able to go convert the keys and the values, because how you store those things in Redis, for example, it might be a string or a byte array, and that's going to imply some type of serialization. Whereas when it was in memory, if I jump back to the bit faster one, for example, I can actually declare in memory that the cache is of type whatever key I want and whatever value I want. So no serialization necessary, but with something like Redis, I will in fact have to go serialize. Okay, so that's a couple of different layers of the cache that we might want to look at, but what about how we join them together? So I do have this multi-layer cache object, and how this works is that it takes in a list of the different layers and still implements the same type of interface where it will actually go have all those methods like try, get, it has the set method, a refresh, and a remove. And all that it's going to do is basically do iteration over those layers. And it treats them in a particular order. So, for example, when we try to get something, it will try to get it from the in-memory cache first, and then from there, if it can't find it, it will fall back to the other layers. Now, what I thought was interesting, and this is where someone else who has their own dedicated library for this that's well used, there's probably a lot of things, like caching's quite complicated, so there's probably a lot of other behavior to consider. But one thing that I was thinking of was that if you were to pull from a particular layer of the cache that was later, so for example, the in-memory cache misses because maybe it is smaller and has a shorter time duration that things will exist in the cache, and then let's say it hits the cache in Redis. I have this method, or this part of the method here rather, that with an option we can turn on. If we missed the cache in earlier layers, I can actually go set that value. So depending on your caching needs, if you're finding that you're hitting the cache in a sort of a further out layer or a lower layer, that's a little bit more expensive, right? Going to something in memory should be basically instant. Having to go to Redis is still going to be very fast, but it is going to be slower than directly in memory. That would mean that if you know in your particular case that you want to have, faster access the next time, you can sort of populate the earlier layers of the cache. And it is an option because maybe you're like, I don't care, at least hit the cache. If someone wants to go set it because that's how your application's flowing, then the next time you go to set it, will set it on the inner cache. So with that said, let's go jump to the set method. So set async, you can see here, all that I'm actually doing is running in parallel for all the layers we have just to go set the key value pairs, right? So it's just a little bit, this is kind of gross. I do have this interface problem that I couldn't really figure out because I can set things like the time intervals, the cache entry options per entry or not. But regardless, if you just look at one of these code paths, the idea is that per layer in parallel, I'll go do the setting. So that means on a particular set of the cache, it will go populate all caches. And like I said, if I go back up to the get, you can opportunistically go refresh the inner caches if they were to miss and an outer or lower layer cache were to hit. But it's an option. So I'm going to play around with this, and when I do some performance analysis, then that way I can validate whether or not this is handy. All right, so that's a quick overview of my multi-layered cache. I did say that we were going to look at these result sets, and I'm going to follow up with that in the next video because I think it was important to get this out of the way so you can see the different layers, understand why I want a multi-layered cache, and understand why I wanted to build it on my own to kind of experiment and explore. But in the next video, which I'll link at the end of this, we're going to look at what we do once we're trying to query a database with a particular filter and how we'd actually like to cache those results. And you'll see how the multi-layered cache comes into play when we look at the implementation of that. So thanks for watching, and hang around for this video right here.